Hello, my name is Kamal and welcome to my demo presentation. In recent years, our reliance on home broadband is growing greatly. A global pandemic arrived and we were subjected to lives in lockdown. We were forced to live and work through our computers, and our computer screens became our windows to the outside world. That is until our internet connection broke. And that was frustrating, right? We disconnected and reconnected, we troubleshoot problems, we reset our hubs, and most of the time it didn't work. Luckily, Virgin Media O2 share in our frustration, and they've asked me to try and detect faults in their modem network or broadband network. But not just detect faults, but also try and predict them. And could we understand what causes these faults and potentially fix them in the future, preemptively? And could we also challenge the current working standards, such that we could maybe change some parts of our infrastructure to prevent faults entirely? So, what is the broadband network? Every Virgin customer has one of these in their houses, which is a modem. And the modem is essentially a gateway through which all of your incoming and outgoing signals pass, internet signals. And what the modem does is it translates these signals into something that's actually interpreted by your computers. So it turns some waves into zeros and ones. The modem is connected by coaxial cables or old-school TV cables to street cabinets. And these street cabinets are connected by fiber optic cables to hub sites. And that is essentially the entire network. Now, a quick word about faults. For us and for our modeling, the best way we could define a fault was a customer calling up and saying, hey, I've got a problem. And the customer service agent would categorize the faults into three places. Clear is where the customer service agent has decided or has fixed the problem. Stage is where they've decided that it's a network problem and that a truck needs to be sent to maybe a street cabinet or a hub site to fix it. And truck, where the truck is sent to someone's house and the engineer is going to have to go fix the problem there. For the rest of this talk, I'm going to talk about stage faults, because why would you want to send a truck to one person's house when you can send it to every person's house, like just in one place? And a quick word about the actual major challenge of this project, which is the imbalance. It turns out that most of the modems are actually working most of the time. So if you had 100,000 modems, and say one wasn't working, say our model actually correctly predicts that one modem, and it predicts 99,998 of the working ones correctly, but incorrectly classifies one of those 99,999. We now have a 50-50 chance of our model being correct, and therefore the problem is actually just quite difficult. But the model itself, I used a tree-based model, and the main reason for this is that it allows something called feature importance. And what that means is that our model can tell us which of the data we put into the model is actually useful and important to characterizing a fault or not a fault. And the data we used was taken over 20 of these subsites with the most faults over 2 weeks. And we used data which was 96 to 48 hours before the fault, or before the phone call for the fault stage. And that is, can we actually predict 48 hours in advance a phone call? And it turns out we can. We were able to correctly predict 46% of stage faults, and we were correctly predicting 99.96% of working modems. Now, the data scientists among you will know that I can tune some thresholds, I can reduce the 46% and slightly increase the 99.96%. But in reality, it wasn't robust enough to get to the 99.999% that we needed. But we have really strong predictive power, and 6 months instead of 6 weeks, there's a lot of potential to develop a fault predicting software. And with that, we could reduce costs of finding faults, we could preemptively fix faults, we could reduce call center costs, increase customer retention, and improve brand recognition. That's all. Thank you.